Hello, everyone. Thank you so much for coming. My name is Luna, and I am a Master of Science student in computer science. I graduated from bachelor's in here. And today, as you can see, we're going to discuss patterns in coding questions. So I have one software engineering internship experience, and I've been through several technical interviews. Some of you can be great programmers, might have built awesome projects, such as games, websites, mobile apps, and more. And when you apply for jobs, these projects will show that you are a great programmer, and you have passion in technology. But then companies want you to prove that you can code. So they want you to code on a whiteboard, live coding. And this is where you will realize that you have to grind leetcode for a while. So leetcoding can be very exhausting. And when you first started, you can be like, what is this question? You might not know how to solve it. So, when you keep solving these questions as you practice, you will see that these questions are kind of alike. They start to sound similar. And this is where you start to notice there are some patterns in these questions. So today, we're basically going to go over some of the popular patterns in technical interviews. And you will learn how to solve these questions faster, more efficiently, so that you won't have to waste your time solving like 100 leetcode questions, and you will just learn how to solve them based on what the question is asking, based on their patterns. Okay, so let's get started. So first, I will go over sliding window. Sliding window is used for linear data structures. What are linear data structures? It is linked lists, arrays, lists, and non-linears are like graph, trees, etc. This pattern is actually also used in dynamic programming, if you have heard of dynamic programming. So basically, patterns are just like skeletons or templates. And once you learn them, once you learn how to recognize them, you can just put the template, you can just apply the pattern and make according adjustments based on what the question is asking for. So sliding window is basically a moving frame on a list to get a satisfying condition. And let me also explain what dynamic programming is for those of you who don't know what it is. Dynamic programming usually asks for like the best possible solution, like most or least number of solutions, optimal solutions. It basically asks you to break down a problem into smaller subproblems. So in here, that kind of demonstrates that we're breaking a whole array into subarrays to subproblems, so that it is easier to solve a question. So in sliding window pattern, we typically start from the first element. Like we have sometimes 2 pointers. One starts from the first element, position 0, and the other starts from position 1, for example. And then we keep shifting by 1, adjusting the length of the window. I'm just reading from the slide right now. In some cases, the window size remains constant. And some other cases, depending on the question, the size can grow or shrink. So how can we identify this problem? How do we know this is a sliding window problem? As I said, it's a question that gives an input that is a linear data structure like arrays. And you're usually asked to find longest substring or shortest substring, or subarray, or a desired value. So you might not know these questions if you are not familiar with LeetCode. I'm not familiar with them either, but we will go over them towards the end of the presentation, possibly if we have enough time. So like you can, as you can see from the title of these questions, it's like asking for maximum some subarray of size k. And best time to buy and sell stock is a very popular interview question. And longest substring with k distinct characters, or string anagrams. And if you don't know what anagram is basically that you can build a string using the characters from another string. So yes, so this question, I'm going to use this question's solution to show you what the pattern looks like. So it's asked, so this is a maximum subarray. It's a medium level question, but don't mind the level. Some easy questions can be trickier than medium level questions. Some medium level questions are like a trickier version of easy questions. So given an integer array, as you can see, we have a linear data structure. It is an array of type integer, and the name of the array is nums. We find the contiguous subarray containing at least one number. So we know the array is not empty. It has at least one number in it, which has the largest sum. And we're going to return that largest sum. So a subarray is a contiguous part of an array. As we saw like on the picture earlier, it's a part of the array. And let me actually go to the link here. I'm gonna stop sharing for a second. Oops, sorry. Spoilers. Okay, let's go to the leetcode question. I'm gonna hide these slides. Okay. Yeah, I know. Okay, so I solved this question before. Okay, can you guys see? I can. Okay, there. This is better. So we have examples here. So this is the given array. As you can see, we can have negative integers and positive integers, of course. And the answer is 6, which means it is the largest sum. And there's an explanation provided. So if we imagine this is a sliding window, first we will start from here and here, and then we sum it, it would be -1. So in the pattern, since it's negative and we're looking for the maximum, we don't want a negative number. We want something that is like big, like positive. So it will make more sense when I show the solution. So we move, and now let me see. So and we move towards in the array, we shift our frame. So now I believe we sum up this part, and it is -2, so it's worse. So now we shift again, we shift from left. So now this is 1. So now we're getting something. And then we move, we increase the size of the frame. So now it's 0. Okay, so it's not negative yet. So we move again. Now it's 2. Now it's 3. So I might get lost too. So guys, you can warn me too. 3. So now we move again. It's -5. So it's negative now, right? So we move from here. We shift the frame. So now it is 3. So now it's 3. It's positive. And then we shift. We increase the size of the frame. Now it's 5, and we move up again. Now it's 6. So far our maximum sum was 6, and then we move up again. -5 makes it 1. So now our sum has decreased. So 1, but it's still positive. So we increase the frame again. Now it's 5. So now we're at the end of the list. So we can stop And as you can see here, I kind of wrote, I'm not sure if this is the example I used. I believe it is. So, okay. So now in the pattern, I initialize the subarray, which is for now, it's just the first position. And I initialize the sum, which is 0. Now I iterate through the array. So as I iterate through the array, I add this number to the current sum. And if the current sum, like I store the maximum value. If current sum is bigger than max sub, basically this is what it does. And this is Python code, by the way. We update the maximum, our result value. So yeah, so if, like, as I said earlier, like we sometimes our sum becomes negative. So, and if you remember, I reset it back to 0 because it was negative, and we're looking for a big number that is not potentially negative. So here we're resetting the current sum. So yeah, this value is kind of used to keep track of it. So does anyone have any questions? I'm not sure if I did a good explanation. Don't hesitate to stop me at any moment. Okay, from current slide. So yeah, this is the pattern. I explained earlier, so I'm gonna skip this for now. Now I'm gonna show another example. It is best time to buy and sell stock. So this question, again, there's an array called prices, and prices at I is the price of a given stock on the ith day. So we want to maximize our profit by choosing a single day to buy one stock and choosing a different day in future to sell that stock. And we're returning the maximum profit. So it sounds very similar with the previous question, right? In the previous question, we were given a linear data structure, and it was asking for us to return the maximum sum. And in here, it is asking us to return the maximum profit, which is similar to maximum sum. So you can see how like similar they both are. So like if you look at this example, we have prices here. So these are like stock prices on each day. Each position represents a day. So when we buy on when we buy on day 2, which is 1, so position 1 in the array, at day 2 the price is 1. So we like investing works like you buy at the lowest price point and you sell at the highest, not the opposite way. So okay. So we buy the lowest point, right, which is price 1. Well, it's so cheap. And then we look at each day and we see 5. Wow, it's so expensive now, and I'm gonna sell it to make profits. And now our profit is $6. Like if you sum these together, and let's see, note that buying on day 2 and selling day 1 is because you can't logically go back in time. So and in here, the reason why this array has output, this example has output 0 is because, as you can see, it's getting lower and lower. So we're not making any profit. So we don't make any profit, it's 0. So this is, if you kind of like try to match the patterns, here we use like L and R as pointers, the left of the array and right of the array. So I'm not sure if I can write on the whiteboard because of the camera, but we start at the beginning of the array and the next day. So we keep comparing the price with the next day. And we initialize our maximum profit as 0, just like the previous question. And then we basically iterate through the array inside the while loop. So R is less than length of the array. So if left is smaller than, so if the price on the previous day is cheaper than the next day, then we calculate the profit, and again we update our maximum profit value. So profit acts like a current sum, just like in the previous question, and max profit is our return value. So we keep updating it whenever we find something that is larger than max profit. And if it's not, if the next day is like worse, it's like smaller, that means like we cannot make any profit. So we go to the next day. So we shift our frame and we set our left pointer to right pointer. So we skip those days because we cannot make profit. And then we gradually increase the frame by incrementing R. And then finally, we return the maximum profit. Does anyone have any questions? Can you guys kind of see the pattern? Two pointers. So 2 pointers is different from the sliding window. We have 2 pointers that start from the beginning of the array and the end of the array. And we keep comparing or like calculating the value at the beginning of the array and end of the array. We can call these pointers like left and right. So we need 2 pointers. The way 2 pointers help us is if we had to like use 1 pointer and like just like I in a for loop, we will like keep like looping back and forth in the array to calculate to find like our target sum or like our solution. So in the picture, so this picture seems to ask the target, the sum, the result using 2 numbers. So we keep 2 pointers and we try to find the target sum, which is 6. So if for example 1 plus 6 is greater than target sum, then we decrement right because it is too big. So so this array is also supposed to be sorted. If it's not sorted in the question, then you will sort it. So because our values are greater than what we're looking for, we decrement right pointer to find a better result. And let's say like we now decremented right pointer, right? So now we're summing up 1 and 4, and it is less than the target sum. So now to find our target sum, we will increment left because we're trying to find a larger value. And if it's the result we're looking for, then we just return it. It's kind of like, if you guys know binary search, it's kind of like binary search, but in binary search, we will make it more efficient by adding a variable named mid so that it doesn't go through the whole array. It's just like focuses on a particular part of the array to find this more efficient solution. So let me see. So yeah, so 2 pointers is a pattern where 2 pointers iterate through the data structure. And it is useful when we are searching for pairs in a sorted array or linked list. So yeah, this is an example. So we will look for more examples in a moment. So how can we identify this pattern? How can we understand if this question is a 2-pointer question? So it will be sorted, or want you to sort it. And you need to find a set of elements that have to match a target value. Just like in the previous question, we were looking for a target sum. And it can be a pair, it can be triplet, or it can even be a subarray. So common questions that use this pattern. So pay attention to the titles of the questions. Squaring a sorted array. So and then intersection of 2 arrays. Triplets that sum to 0. So we're summing up three. That is like, it's very similar to previous question I showed. Our target value is 0, and we keep summing up three triplets and find like whichever that sums up to 0, and comparing strings that contain backspaces. So the question I'm gonna show is the example I'm gonna show is 3 sum clauses. So here it is using a triplet, and we're given an integer array, again linear, and we have a target. So that's how we like it. As we like learned like previous slides, it's looking for a target value, and the array is sorted, or it wants you to sort it. And we find 3 integers that sum up to targets if possible. So in this question, we find whichever is closest to that sum. So, and there's a constraint. You may assume that each input will have exactly one solution. So there is, we definitely have a solution. So there has to be a solution, because we're not looking for something that is exact to our target. So here we have 2 examples. So we have -1 to 1 and -4, and our target is 1. So we're returning the sum that is closest to 1. And the triplets that sum up to almost 2 is -1, 2, and 1. And those sum up to 2. So if we were to like sum up others like 2, 1, and -4, that would be 1. No, sorry, -1. Yeah, that would be -1, which is I guess we have 2 solutions here. So yeah, so I guess we can have 2 solutions here. I'm not sure if it matters. And we have an array that is full of zeros, and our target is 1. So like whenever we sum, it's always going to be sum up to 0. So our closest solution is 0. So this is what the pattern for 2 pointers look like. So first, like as we saw earlier, it wasn't sorted. So because we're going to use 2 pointers, we have to sort it. So we first sort it, and then we initialize our result by adding up the first 3 elements in the array, and then we iterate using a for loop here. You can absolutely do this differently. It doesn't have to be exactly this way, but I'm just showing what the pattern looks like. So as we iterate through this array, we have 2 pointers, left and right. And left starts from like the beginning, or almost beginning, and right starts from the end of the list. So here we keep updating it as we iterate through the array. Left is i+1, and right is the end of the list. So now so while left is less than right, it has to be less than right because they're in opposite directions. We keep summing up triplets using the 2 pointers and the I index. So and then if sum is like larger than what we're looking for, then our right pointer is too big. Because we sorted it, it's ascending order. So right pointer is too big, so we decrement right to look for smaller possible solutions. If it's opposite, if sum is less than target, then we decrement left pointer. So, and then we try to find our closest solution in that if statement. So we take the absolute because it might be a negative. So we were trying to find the difference. So if if sum that we found in those in the triplet in the for loop minus target, if the difference is smaller than what we have found so far, then we update the result value, and finally we return the result value. Any questions? fast and slow pointers. So this pattern is typically used for linked lists. And you can imagine like there are two cars. One is going very slowly, one is going very fast, and they're on like a circular road that is only one lane. So the fast car like always like passes the slow car, and then at some point they collide because the fast car is going too fast and it will just crash. That's where we find a cycle. So this pattern is typically in linked lists, typically used to find a cycle, which is also a very popular technical interview question. So so basically we use 2 pointers that is kind of adjustable for linked lists. And these 2 pointers move through the array or linked list, and they have different speeds, as I said earlier. And yeah, this is typically used for cyclic linked lists or arrays. And yes, they crush eventually, if you imagine they are cars. And that indicates that there is a cyclic loop going on in the data structure. So how can we identify this pattern? How can we see if this is asking for this pattern? Is we need to know. So it will ask you something like find the cycle, find the loop, find like something like that in a linked list or array. And you need to know the position of certain element or overall length. So you are given a length or certain element. And there are some cases where you shouldn't use the 2-pointer approach, such as singly linked lists, because we cannot move backwards in backwards direction. So yes, and like another way to use this is if you're trying to find if the linked list is a palindrome. And what palindrome means is that when given something like string, array, linked list, whatever, when you reverse it, it's going to stay the same. So for example, mom, M-O-M, when you reverse it, it's still going to be mom. It's a palindrome. So yeah, common problems that use this pattern is, as I said, linked list cycle, palindrome, linked list, or cycle and circular. So these are the keywords: cycle, palindrome, circle, cycle. Like yeah, so it's kind of like very obvious to see that you can use this pattern. So I'm gonna show a very typical example. So this is a linked list, and we are given a head, and the head of the linked list determines if the linked list has a cycle in it. So I'm just reading the question here. There's a cycle in a linked list if there's some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that is tail's next pointer connected to. And yes, position is not a parameter in this question. And if there's a cycle, then we return true, otherwise we return false. So here we have an example. So imagine we have like a slow car and a fast car. The slow car will start at 3, node 3, and the fast car will start from 2. I might be wrong, so we will find out. So and the slope will go step by step, 1 by 1. So it will be 2 next, 0 next, and the fast will just skip like will go from 2 to -4 to 3 to 0 to, and eventually they're going to collide, and that indicates that there is a cycle in the list. So let's see the pattern. There are more examples. So yeah, do you have any questions? Okay, so here's the pattern. So since like it is, so if linked list is null, then we just return false because there's no possibility of cycle. And fast will start from 1 position forward, then the slow one. Slow will just start from the beginning. So so we check that we're not going out of bounds. So while a condition is just the condition that avoids us to exceed the that we don't run into any null elements. So if fast and slow is equal, that means there's a collision. So we return true. And with the way we increment fast is we skip, as I said, it goes very fast, and slow just goes one by one. It just goes to this next one, and then the next one, and then the next one gradually. And then if it doesn't return true, it just returns false. So yeah, merge intervals. What time is it? Can I check the time? Okay. So merge intervals. So this is also very popular. I mean, these patterns were popular from the beginning, I said. So this is a bit tricky. When you solve leetcode questions, you might forget them sometimes. So this is a reason why patterns are useful, and I keep forgetting this question. So this is very efficient when you're, as its name says, you're dealing with overlapping intervals. So what does overlapping intervals mean? We will see in a second in a question. So we have two intervals, A and B. So it's typically a multi-dimensional array. And there will be 6 different ways the two intervals can relate to each other. So okay, I will keep that to the next example. So just understanding these rules, these are 6 rules for overlapping. You can kind of think of them as conditions. There are 6 cases that will help you to determine if this is overlapping or not, and optimizing this problem. So the way to identify this pattern is you're asked to produce a list with only mutually exclusive intervals, and you hear the term overlapping intervals. So it's pretty simple to kind of recognize this question, but the pattern might not be as easy as others. So common problems using this pattern is interval intersection. Intersection means kind of it's overlapping, and maximum CPU load, which sounds scary. So yes, I'm going to show a very typical question. It's very likely that you might be asked this question in a technical interview. So we're given an array of intervals, a two-dimensional array, and each of the arrays have start and end. And so we're merging all overlapping intervals so that they're kind of in order. And we return an array of the non-overlapping intervals that cover all the intervals in the input. So here we're given 2 examples. So we have 1, 3, 2, 6, 8, 10, 15, 18. So I mean, it's already given. I was gonna ask what is your understanding of overlapping intervals? How does this overlap? Can anyone see the overlapping? If there's an explanation there, you can cheat. So it's to not overlap, they have to kind of sort of be in order. So 1, 3, 2, 6. Now there's an overlapping in here because 2 is coming after 3. So we have to kind of merge these the first 2 intervals. So it should be so it's this the second position in the first interval and the first position in the second interval is breaking this rule. It's making it overlap. So we merge these 2 intervals and we make it 1, 6. So we basically get rid of those elements that cause this overlapping. And then, so let's say we are left with 1, 6, 8, 10, 15, 18. Now, do we have any overlapping intervals? So 1, 6, 8, 10, 15, 18. We don't have anything that is overlapping, right? So this is our solution. And in the second example, we have 1, 4, 4, 5. So it shouldn't be equal either. So it should be strictly like in order, kind of. So we merge these two intervals to make it not overlap. So we will merge it to 1, 5. And that is the solution for the second example. So this was my own solution. So there might be way better ways to solve this. So the length of if the length of the interval is 1, if we have only one interval, then we basically just return that. And then we sort it. So we sort it based on the first position in the interval, so that it's easier for us to solve the question and find out what is overlapping or not. So we initialize our output. Do you see how like we always initialize with like the first element in the array? So you can kind of like start solving a question with initializing things, and then it might just come step by step. So, and then we initialize the maximum value, which is going to be our return value. And then we iterate through these intervals. We start from position 1 because we already added the first interval to our output. So, so our current interval is right now the second interval in the position of the array. So if the last, so -1 in Python, basically when you add -1, it means the last element in the array, or first, whatever it is. So so the last thing we have in the output, we compared its second position with the current interval's first position. So normally, to not overlap, the current should be greater than, because it's coming after the output, because we remember we sorted them. So it should come after, but if it's less than instead, or equal, then that means there's an overlapping. So this is a condition that we showed earlier on, like here. So which one would it be? I think it would be 2. Yeah, condition 2. Yeah. Yeah. And then so we find like whatever is maximum, because we're going to merge them. So we decide which second position is bigger, and the biggest second position we find, we change the output's second position to that greater element, so that we merge those overlapping intervals in a way that it's like sorted, just like in this example. So like in 1, 3, 2, 6. So in our output right now, we have 1, 3, and our current interval is 2, 6. So we compare if the second position of the output, 3, is less, or is greater than, because it's sorted, is greater than the first position of the current interval. So if it is, then we look at 3 and 6. So 6 is larger. So we change the outputs in the last interval in the outputs second element to greatest value, which is 6. So it will be 1, 6. Yeah. And if it's not overlapping, then we just add it to our output, because it's perfect. It's not overlapping. And finally, we return our output. Does anyone have any questions? Okay. Feel free to stop me. Okay, this was the end of the slide. So what time is it? So my goal was to, okay. So we have around like 20 minutes. My goal was to finish this in an hour. So I can show like questions and let you figure out what pattern it is. So let me kind of hide this. Okay. Let me, yeah. Okay, let's find a pattern. Okay. Okay. Let's see. Sliding. Oh, sorry. I said, okay, never mind. I'm just gonna show it. Um, hmm, okay. So let's show this. Let's show this, yeah. Okay, it's coming up. Let me drag it back here. Okay. What do you think is this is? Okay. Who says this is sliding window? Yeah. Can you guys see? Okay. I'll give you a second to read it. Okay. Are you guys ready? Who says sliding window? Who says two pointers? Who says fast and slow pointer? Who says merge intervals? Yes, it is sliding window. Correct answer. And how did you know it's sliding window? Anyone wanna volunteer? Why do you think this is sliding window? And yeah, basically, yeah. Okay, let's okay. Let's see. Okay, let me show this. Okay, let me give you a moment to read it. Feeling ready? Okay. Who says sliding window? Who says two pointers? Who says fast and slow pointer? Who says merge interval? Does anyone want to take a guess? Anyone else? What do you think is a merge interval? My instincts are telling me it's merge interval. Any other guesses? Don't be shy. We're all learning, so. Mm. That's a good point. Anyone else? The answer is sliding window. Why do you think it could be a sliding window? Yeah, it is a hard question, as it says. It's meant to be hard. Anyone else why do you think it could be sliding window? There are some keywords in bolded letters. Mm-hmm. So they bolded it for you to make it easy for you to recognize it. Yes, subarray and contagious, meaning it's like sliding. It's a subarray that is sliding, contagious. So yeah. Let me do another one. Um. Okay. Let me give you a second to read it. This was in the slides, by the way. Anyone feel confident? So confident? Want me to ask? Who thinks it's a sliding window? Who thinks it's sorry? Did anyone say something? Who thinks it is two-pointer? Yeah, it's two-pointer. Because it's in non-decreasing order, so it's sort of sorted, and we're finding the squares of each number. So yeah, let's find another one. So um, which one should I ask for next? Okay. This is a good one. I'll give you a second. I'll show the like examples too. Can be a little tricky. Pay attention to italics, emphasis on description. Anyone feel confident? Who thinks that it is a sliding window? Who thinks it is a two-pointer? Fast and slow pointers. I forgot. Who thinks it's a merge interval pattern? Was there any other? Yeah. Okay. Why do you think merge interval? that makes sense. Who else said merge interval? I'm sorry. Do you think the same? The ones who said fast and slow pointer, why do you think it is a fast and slow pointer?
Slow pointer starting at the first of the head node, then the fast pointer continues to advance. So the fast pointer starts at one after the head node. It continues to advance the rest of the list. And for every time that the fast pointer is equal to the slow pointer, we just ignore that one and keep one copy. You advance the slow pointer to the next one, restart the fast pointer at the one right next to the slow pointer.
You gave the whole algorithm. Yes, it is fast and slow pointer. Okay. Let me ask. Let me do this. Let me do this. Let me see. I'm not gonna ask this. Let me see. Reorder. I'm trying to find a good question that is not too hard. Give me a sec. Almost there. Okay. Yeah. Take a moment to read it. Now, this pattern should be pretty easy to recognize because of some big hints in the title and the description. You guys feel confident? Who thinks it's a sliding window? 2 pointers. Fast and slow pointers. Merge intervals. Yes, correct. It's the merge interval. Why do you think it is a merge interval? Anyone volunteering? Do you guys want to shout it out loud? You don't have to. Because basically, it says interval, and you're inserting intervals you're inserting a new interval to the interval, which is kind of like merging, like modifying these intervals, the list. So yeah, and it's also sorted. We have 5 minutes left, so I'm gonna ask more, and I'm kind of having fun. Okay. Let's see. Oh, this is interesting. Let's take a moment to read it. You guys feeling okay? Confident? So confident, not so confident. Who says it's a sliding window? I see small fingers, not so confident fingers. Who thinks it's a two pointers question? Who thinks it's a fast and slow pointers question? Don't be shy. Who thinks it's merge intervals? We don't like merge intervals for this question. Why do you guys think sliding window? Why? Yeah, good point. Yep. Yeah. You? Oh, okay. I'm seeing. Well, it is a. Did anyone say two pointers? I just saw like small shy fingers. Okay. The answer is sliding window. And you guys are right. It's asking for a maximum solution. It's moving. We have, yeah, it's moving left to right. It's a linear data structure, right? That's why we don't like merge intervals here. Yeah. Did you guys like me showing you guys surprising? Does anyone have any questions? Okay, so I'm gonna repeat your question because Mike doesn't sometimes. So he's asking what interviewers are looking for in technical interviews. Did I hear correctly? Well, they ask these kind of questions because not because they want you to get the solution right away. And if you start coding right away, that's usually considered a red flag, no matter how confident you feel. They want to see how you approach a problem. They want to see how you think, how you solve a problem. You gotta show them that you think like an engineer, like I actually was debating if I should do live coding to show you guys like how to kind of walk through this solution, like problem. There is a strategy called Umpire, Umpire. So I'm not sure if the whiteboard will catch it, but for our attendees, I'm going to show it. So Umpire. And let me know if you cannot see the letters because I think it's kind of blocking. Can you guys see? He cannot see. Oh, okay. Let me just do it here. Is it better or worse? Oh, right. I'm just gonna type on there then. It's much easier. Sorry, webcam. Okay, let's open up notes. Notepad. Make it, yeah, make that bigger. Umpire. I don't know why I was drawing on whiteboard earlier. This is easier. Okay. So has anyone heard of umpire before? Little? Umpire. Oh. Well, So this is kind of like a shortened version of something. So U stands for understand. Understand. M stands for match. P stands for, any guess? Huh? Sorry? Pattern? No, it stands for plan, but very close because you might be like, oh, this pattern looks good for this question. I stands for implement. You are wrong. Huh? Review. Recursion. E stands for E. Screaming in technical E. E stands for evaluate. Now, understand. So when, let's say they asked you to reverse a linked list. So when you're given a question, you're not gonna be like, oh, I know how to solve this. Here's the full solution. So first you should like, approach the solution by first reading the question. Of course, you will read the question. Read it out loud, don't read it inside. If it helps you to read it inside, then you can read it inside, but read it out loud because you're working together with the interviewer. You're demonstrating that you're working with them together right now. So understand stands for understand the question. Understand the constraints. Are there any constraints? Can this list be empty? Can this list be character array, integer array? Can there be negative numbers? And you gotta make sure you understand fully. And match stands for, I think this is a two-pointer question. I think this is a sliding window question. Now the interviewer might be like, what are those? I don't know. You can elaborate on that, which will kind of be impressive. You can be like, oh, it's a sliding window because like, what I imagine is like array kind of like, of course, you might not get it the first time. If you're seeing the question for the first time, you don't have to be perfect and be like, oh, this is, I know I'm a pro. I've done 100 leetcode questions. So yes, this is a sliding window. So you don't have to like be perfect. You're thinking out loud. So make sure you think out loud. Don't think inside. If you're stuck, tell them like, yeah, I'm stuck right now because I'm not sure how to sort this, or I'm not sure how to fix this logic thing that you're stuck about. So match stands for pattern, data structure. Like you can be like, I'm gonna use hash maps. I'm gonna use graphs, graph theory, binary search, divide and conquer. Stuff like that. So you're thinking that like you're like, oh, you know, I can solve it like this. This is what I think. It might be incorrect, but I'm just thinking out loud. And then you're starting to get into planning. So planning can be pseudocode. Do you guys know what pseudocode is? Does anyone know not know what pseudocode is? Yeah, it doesn't have to be real code. You're just writing like function, return, blah, blah, blah. So it doesn't have to be pseudocode. It can be English sentences too. So that is to like kind of sketch out like let's say you're building a house, like you're drawing like the, you know, architecture, something like, I'm not an architect. So yeah. So yes, you're making a plan. You're showing them how you might solve this problem, what your approach is. And then when the interviewer is like, I don't think there are any problems with your approach, or I think this algorithm will work, or I think like, yeah, I think you're correct. Then you start to get into implementation. Now in plan, you don't have to make it perfect. You don't have to take care of everything. That's going to happen in implementation. In implementation, you have to be like detail oriented. You have to be like, oh, I've thought of this special case. What is it called? Like corner case? I forgot the exact keyword. Edge case, yeah. I thought of this edge case, like for example, it can be empty. List can be empty. Edge case basically means like unordinary situations. Like the list can be empty. The list can be like unordinary situations. So in implementation, you write actual code. But like some companies don't necessarily want you to write real code if you are not going to compile it. That's called whiteboard interviews. Like Google makes you literally write code on Google document. So you write like code, but not like you don't have to compile it. You just have to express your thought process and review. Now when you first code it up, you might not see some logical errors. You might not see that you have covered most cases. And in review, you're going to look at your code and be like, let me see if I have made any mistakes. Let me see if I have any logic errors. Let me see if I have any syntax errors. And you review it. That's called reviewing. And there's evaluate. Now, not all companies might be like, now tell me what the time complexity of this is. What is the space complexity? Do you guys know what time complexity or space complexity is? Time complexity is like how fast, like estimated, how fast can it run? There's like linear, constant mean size, like very fast. It's 0.1. Like it just goes like, let's say like, this is like the size, or sorry, I think it's the opposite. So this is like the size of the data we have, and this is the time. So this is like constant. It's like it's always the same. It's very fast. It's like quick. And okay, I always mix up like constant and linear. So constant is like basic. And this is linear. So it is of n. Just like math, like there's like n squared means quadratic. Like, yeah, like log n. This means that it's, oh, wow, that's very fast. Like binary search is log n. It's basically means that like O of n means that you're going through all of the array. You're going through like n number of like, for example, if there are 100 elements in the array, you're going through 100 elements. And log n is like, you're going through like half or a little, like less than that. So I think like I might be wrong, but let me erase all this. Like O1 is like the fastest. I'm gonna say like equals. Of log n is the next most efficient time complexity. Of n is the next coefficient time complexity, and then there comes n log n, and then like there is like O of n squared. There can be like O of like it can like go like worse. So yeah. And then are there any questions? This is time complexity. And I mean, we can cover this in another workshop, I guess. This goes into a whole different like thing. You will learn about this in your algorithms class. And then we have space complexity. Space complexity is for if you're using any additional data structure, like you're creating a new list of size n. You're returning a whole new list, a separate list. Now, since it has like length of n, the space complexity, the additional space we take on memory is O of n. because we have like n elements in the new list we are creating. So I'm not very like proficient at this, so I'm gonna leave it here. So yeah. Any additional questions? Any follow-up questions? Yes. There was this time when I was like supposed to code in JavaScript, and I'm not very, very familiar with JavaScript. And they told me, what is the time complexity of this? And I was like, I had like one while loop, and I was like iterating through all of the array of size n. So I was like, oh, this is linear O of n. But then interviewer was like, that's wrong, because this function you're using is using another O of n. So this would actually be like this is inside. This would actually be O of n squared. This times this. Another time, so sometimes like for internships, sometimes they ask, like I interned at American Express, and in that interview, they asked me like, I believe they asked me, I might not fully remember, but they asked me something related to comparing search algorithms. What is the difference between, for example, like bubble sort and merge sort? Merge sort. So those are fundamental things that like they can ask things like that. There's actually a website called, let me see if I can open it up. Time complexity cheat sheet. So this website is very, very useful. It will be useful in your classes too, in your algorithms class. So like it just shows like what I just showed earlier, like the best case to worst case. So like horrible. These are horrible. And like common data structures like array, accessing an array, like an element in array, like you will do like array at position 1. It's like constant. You just like, because you know the position, you will be like, yeah, this is a 5th position in the array. Searching, because like you're searching in an array, like you go through the whole list to find it. It's O of n. And like, yeah, like I'm not gonna go over all of them. So basically, like this website like is a cheat sheet for you to take a look at. You're not, you don't have to memorize all this, but at least know the fundamental ones like arrays, like sorting algorithms come up a lot, like merge sort, bubble sort, insertion sort, like the popular ones. You don't have to know like bucket sort, like radix sort. Those are like very, not very common ones. Yeah. Yeah. Any other questions?